Today we are going to discuss the job number 8 to perform experiment on the double acting reciprocating pump and to determine coefficient of discharge and the slip of the pump. The operators for this job: double acting reciprocating pump, discharge measuring container, tachometer to observe the number of revolutions, and the stopwatch. Now the part of theory. First, look at the reciprocating pump. What is meant by reciprocating pump? Reciprocating pump is a machine which converts mechanical energy into hydraulic energy by the reciprocating action of the plunger or piston in a cylinder. It is also called a positive displacement action pump, as it discharges a definite quantity of liquid during the displacement of its piston or plunger in the cylinder. The reciprocating pump is always used for providing very high pressure. So this is the figure, the photograph of the double acting reciprocating pump. And here in this particular slide you can see the single acting reciprocating pump and its different components. So as far as single acting reciprocating pump is concerned, a single acting reciprocating pump is one which has one suction valve, delivery valve, and one suction pipe and delivery pipe. It sucks up the fluid only in one direction and in single stroke, called suction stroke, and delivers it in a single stroke called delivery stroke. So here you can see the different components like connecting rod, crank. You can see here the suction pipe, you can see the delivery pipe, you can see the piston, and we'll be having the to and fro motion of the piston. Well, this is again the single acting reciprocating pump, showing the main components of the single acting reciprocating pump as you have seen on the previous slide. Now on this particular slide, some useful information regarding double acting reciprocating pump is given. In case of double acting pump, the water is acting on both sides of the piston as shown in the figure. Thus we require two suction pipes and two delivery pipes for double acting pump. So this is very important thing associated with double acting reciprocating pump. When there is a suction stroke on one side of the piston, there is at the same time a delivery stroke on the other side of the piston. Thus, one complete revolution of the crank, there are two delivery strokes and water is delivered to the pipes by the pump during these two delivery strokes. Now this is the schematic diagram of the double acting reciprocating pump. You can see there are two delivery valves, two suction valves, and again we will be having the piston to and fro movement. Now this is the figure 8.2, that is the schematic diagram for double acting reciprocating pump. And here you can see there are two suction pipes and the two delivery pipes, and the two delivery pipes have been connected to one like this, and we are having the connecting rod. This is the piston, and you can see the delivery valves and the suction valves. Theoretical discharge. It is the discharge of the reciprocating pump, which is computed on the basis of some theoretical equation. For double acting reciprocating pump, this equation is to be used to determine the theoretical discharge. And here in this formula, L is the stroke length, that is obviously equal to the twice of the radius of the crankshaft. A is the cross-sectional area of the piston, and that is obviously pi by 4d square, where d is the diameter of the cylinder, n is the number of revolutions of the crankshaft per minute, and q is the discharge of pump. Then the actual discharge. Actual discharge, it is the discharge which is actually produced by the pump, and this can be determined by dividing the volume of the container in which the water will be collected divided by the time required to fill that container. Then there is a very important term that is called as slip. The difference between the theoretical discharge and actual discharge is known as slip of the pump. It is often expressed in percentage. So actually slip is equal to Q theoretical minus Q actual. So when it will be determined or expressed in percentage, so percentage slip will be expressed as the difference of the Q theoretical and Q actual divided by Q theoretical multiplied by 100. Sometimes actual discharge may be more than the theoretical discharge, and this is known as negative slip. It happens when length of delivery pipe is very small as compared to the suction pipe, and pump is running at high speed. Delivery valve opens before the completion of suction stroke, and some water is pushed in delivery pipe before piston commences its delivery stroke. Then coefficient of discharge. It may be defined as the ratio of actual discharge to the theoretical discharge. It is denoted by C sub D, and this C sub D is equal to Q actual divided by Q theoretical. Then the term of volumetric efficiency. It is the coefficient of discharge expressed in percentage. For zero slip, the volumetric efficiency is obviously 100%. So mathematically, the volumetric efficiency is equal to Q actual divided by Q theoretical multiplied by 100. Then look at the table for observations and calculations. Here, first thing which is mentioned, that is the volume of the container. In the laboratory, the volume of the container that we are using, that is having the volumetric capacity of 5 liters. And you know this thing that 1 cubic meter is equal to 1000 liter. Then the next thing which is mentioned over here, that is the stroke length. In our case, the stroke length is 1.5 inches. And then the next thing is the diameter of the plunger, and that is equal to 2 inches. And then the next thing is the area of the plunger, that can be calculated by using the formula pi by 4 d square. Now look at the table of the observation and the calculation. You can see three observations, set of three observations will be there. The first column after serial number, you can see that is the number of revolutions per minute. Then we are having the Q theoretical, and that is obviously in cubic meter per second. Then time t, and this is the time for the collection of 5 liter of water. And then you can see the actual discharge, that is equal to volume collected divided by time, and obviously it will be determined in cubic meter per second. And then coefficient of discharge will be calculated, then slip will be determined, and then volumetric efficiency will be calculated. So in this way you could be able to tabulate the values, and then you can determine the average N value, theoretical discharge, the time for the collection of 5 liter of water in the container, average value of the actual discharge, average value of the coefficient of discharge, average value of the slip, and the average value of the volumetric efficiency. Now look at the procedure. The procedure involved in this job. First step is switch on the motor of the pump. Measure the discharge by noting the time required to fill the 5 liter container. Next step, to measure the RPM of the crankshaft. Then you will have to repeat steps 2 and 3 three times at least to have mean readings. And then results. The final results can be tabulated over here, and here if you just look at the serial number column, the first one is meant for the slip of the pump, number 2 the coefficient of discharge for the pump, and number 3 the volumetric efficiency of the pump. So you can report the average values over here in this column. And here the units, obviously there will be no units for the coefficient of discharge. And then you would find some place to write a few words under this particular block under the heading of comments. So you will have to focus on the results, and you will have to write few sentences over here.